Seagull SWAT is a game concept created by a student in my interactive design class at Kendall, and I'd like to share with you how to write some ActionScript to dynamically generate some game characters. So here is our full portrait orientation game area, and we will be concentrating on the top 2/3. I'll publish the movie here. And some of this is cut off because the display resolution is bumped up a bit here to make it easier for you to read the code in the video. But we have this single seagull movie clip flapping its wings here, and we want to dynamically generate a whole flock of them all over the sky to go ahead and fly by. Now this, for the purposes of this project, that just serves to add some dynamic random elements to the title screen, but it could certainly be used to begin actual gameplay itself. So let's take a look, and the very first thing that we want is we want to make sure that we can communicate with our Seagull movie clip in ActionScript. So here we have our Seagull movie clip, and inside of the library we want to find the Seagull movie clip, and the most important thing is to right click, choose properties, and under advanced make sure you select this export for ActionScript. Gives it an ActionScript linkage identifier. We gave it a name Seagull with capital S for the class, and it extends the movie clip class. So now we can create instances of this movie clip, of this class, in ActionScript. One thing I like to do is, even though we're creating them dynamically, it's always nice to have a copy of the movie clip on the stage. So I typically, here's where the animation of the wing flapping was done. So I typically keep a copy of that on the stage and make a guide layer out of it. So again, anytime you want to have something on stage that's there for you to edit, and you don't want it to show up when publishing, you just select a layer and choose guide. It'll turn into a guide layer. So that's useful for having a visual way to work with the game asset, even if we're dynamically generating them all in code. Okay, so let's just go into the right here. I won't go into the setup of the timeline, the rest of this layout, but we're just generating all of this on a keyframe inside of a movie clip where we want to generate these characters. So we open up the Actions panel with that keyframe selected, and currently we just have a stop command. Incidentally, the completed source code for what I'm about to go through is, of course, listed in the blog post below. So let's go ahead and start creating some seagulls. So the first step is to create a new seagull. So we want to put that in a variable named Seagull with a lowercase s of type Seagull with the class we just created, and we'll create a new seagull with that. Okay, so now this actually creates it, and now once it's created, now we actually need to add it to the stage. We have an empty movie clip sitting in the upper left corner of our stage that we named Seagulls. So we're going to go ahead and target that movie clip and add child Seagull. So this should create a instance of our class that we set up with the linkage identifier over here, and it should simply add it to the stage in the upper left corner where our empty Seagulls movie clip resides. So let's take a look at that. And as we can see, we have now a second one kind of flapping its wings behind the one that's manually placed there. Fantastic. So now let's go ahead and add some random element, and that's a lot of times where generating things dynamically in code can give you a lot of power and a lot of fun gameplay to have random elements happen. So for example, we want that seagull, every time we play, we want that seagull to be placed at a random position on the screen. So before we add it to the stage. We'll say seagull.x equals math.random times stage.stage width. And then similarly, we'll say seagull.y. It's math.random stage.stage height. Take a look again. And our seagull, we cannot see at the moment. It's probably hiding down there somewhere. That's something that we're actually going to come back to. We'll try it again because it is random and it should change every time. Give that one more shot. There we are. Okay, so now we see our seagull randomly showing up down here. Now, before we worry about, here, I'll take a quick look again at the design, and those first couple of times the seagull was probably being placed down here somewhere where it's cut off for us currently on the screen, but we'll come back to setting a bottom limit so they won't go any further down than this, because we really want them to look like they're in the sky up here, so that's all we're really worried about. For right now though, before we do much else, let's go ahead and wrap this all into a setup function. Now, it's a good idea when you're doing scripting on individual keyframes in Flash, especially if it's one that you may leave and then come back to by buttons just jumping in the timeline. We're not going to want to generate all of these seagulls again and have it happen each time we come back to the frame. So we're going to wrap this in a setup function. So what we'll do is we'll create a simple Boolean variable called isSetup. And then we're going to check for it when we enter this frame. We'll say if not isSetup, which by default isSetup is not true. It's not set to anything. Then we want to go ahead and set isSetup to true, and then we will call our function called setup that we're about to create. So that's just a simple little loop that the very first time this frame gets hit when the movie's playing, this variable will not be set up to anything, so it will return false here and go into this if statement, set it to true, and run our function. When we leave the frame and come back to it, the next time this isSetup variable will already be set to true, so it won't run the setup function again. So we'll go ahead and set up our function setup. It's not going to take any parameters, it's not going to return anything. Void, and then we can just place this stuff inside of it. Very nice. Okay, so let's just go ahead and test it and just make sure we didn't break anything in the process. There we go. Okay, there's our seagull again in a random position. Okay, so from here, we officially generated a seagull out of the library, the ActionScript. Now we'd like to generate a whole bunch of them. And we want to set that number in a variable so we can easily change one variable and decide how many seagulls we want to create. So up here, we'll go ahead and create a new variable called num seagulls, set it to an integer, and we'll start out by setting it to 10. Alright, now we're going to have to create a for loop to wrap all of this seagull generation in so that it will generate the seagulls as many times as we set. So we'll say for var I int equals 0, I is less than num seagulls I plus plus. So this for statement just iterates how 10 times now whatever we put in here will go ahead and happen. So we'll wrap our Seagull generating code into here. Clean it up a little. And now when we run it, it should generate 10 seagulls. Very good. You see a bunch of big fat seagulls hanging out on the screen. To illustrate, let's go ahead and up this to 100. And now we are overloaded with seagulls. Okay, so let's take a quick look and see what we set this to in the final. Looks like we set it to 7 seagulls. Well, we'll leave it at, like, let's say 20 for now, because it's a good idea as we're playing with these other parameters to have a lot of them show up on the screen so we can get a good idea of where they could possibly show up since they're random each time. Okay, so here we have all of our seagulls. Now, the next thing we'd like to change is the scale, because they are all the same size right now. So let's go ahead and let's see. Yeah. So now after we set the position, now let's set the Seagull dot scale x. Maybe it's x scale. Let's double check this. Seagull.scale capital X is equal to the Seagull.scale Y, and that just keeps the scale uniform so it doesn't stretch or squash the seagull. And again, we're going to set that to math.random. And since scale is a 0 through 1 number, the random by default returns a number between 0 and 1, so that will work out nicely. And here we go. Now each of our 20 seagulls that will be generated are now different sizes all over the screen. Very nice. Alright, let's go ahead and now we want to, let's fix this area where you can see some wings flapping down here. We want to set a limit down here so all the seagulls will be above a certain line. So let's see, reference the code, Seagull bottom. So now it'll say var Seagull bottom can also be an integer. Well, I believe I was using number in the example code. I'm going to keep referencing that to keep this code exact. Now the difference is negligible. Integer keeps whole numbers, but number gives you a little bit more flexibility if you're not sure if things are going to need to be fractionalized. But for the time being, we'll just leave number to keep it flexible. Using integer, if you wonder why, that will save you memory and performance at a certain level. And we'll go ahead and set this to 500 pixels from the bottom. And now when we place our seagull, stage. Alright, y is greater than seagull bottom. Alright, let's start adding some comments here. Create our seagulls, new seagull, okay. So overall, inside of this setup process, we're going to create our seagulls. And right here is where we generate a new seagull. And then now we are position seagull on stage. Very good. And then down here we are set seagull scale, size, add seagull to stage. Set seagull size, and finally we are going to add seagull to stage. Alright, now our code is a little more readable as it gets more complex. So now we again, we set things up so this code will only run once when we go back and forth in between the frames, which is a common thing, the best practice thing to do when you're just coding on individual frames in Flash. You don't want to double up on things, double up on event listeners and things like that. Now once we're in here, we set a couple of variables. We are generating as many seagulls here as we have in num seagulls, and we are giving them a random position all over the screen as well as a random size with the scale, and we're adding it to the stage. What we've done next is we want to set a bottom limit. So the seagulls, even though they're randomly all over the stage, they will not be past this limit. So after their position, we can just simply check and say if seagull.y is less, let's see, y is greater, because y starts in the upper left and counts positive as it goes down in the Flash coordinate system. If seagull.y is greater than our seagull bottom variable we set, 500 pixels, then we'll say seagull.y equals seagull bottom, which basically means if it tries and goes past a certain point, it will just leave it at that certain point. So now if we test our movie, now we have a bunch of seagulls and none of them are going past down here below this certain point. We wanted to be able to see some of the sandcastles overlap a little. Again, it's a good idea to crank up the number of seagulls to really have a good test case of. So you can see that they won't go down further than they're supposed to. So that's a very nice limit there. Okay, now we want these seagulls to actually move across the screen. So from here we want to add an event listener to our seagulls. So once we, inside of the for loop, to be done X number of times, set it back to 20 for now, create the new seagull, position it on the stage randomly with a bottom limit. We set the size. Now before we add it to the stage, now we want to, let's see, how do we add seagull movement function. And now we're going to set an event listener. So on this individual seagull, we will add event listener, and it's going to be a event.enterFrame, which is a very common function which will run, in this case, 30 times per second. That's our frame rate. And it will run this code inside of this function multiple times per frame, which is a lot of times referred to as the game loop or the game engine, and that's where all of the hardcore calculations that keep track of things on a frame-by-frame basis, user interaction, player controls, character controls, all of that should happen inside of this one game loop. What did we call it? Okay, we are calling it Move Seagulls, for we are using it for the purpose of inching our seagulls along pixel by pixel. And that is set up. So add seagull movement function. So now with each of these 20 seagulls that are created, they will all follow what goes on in this move seagulls function. So let's go ahead and go below our setup function and define that. So function move seagulls. Let's take in an event. It will not return anything. And now we're ready to move our seagulls across the screen. Let's see. The first step, let's see, spelled this out here. The first step is once this function hits, we want to define, since this is going to be happening for multiple seagulls, we want to define which one we're speaking to. So we're going to set up a variable here. Oops. So variable seagull is going to be an object. Just use that generic term rather than the specific capital S seagull class. Equals event.currentTarget, and that will allow us to target the actual seagull that this event is sending from. now we'll put a comment to move Seagull, and we want it to move across the screen from right to left in the direction that the seagull's facing. So we can say seagull.x minus equals, so it will move in the left direction. Let's just do 1 pixel for now. So the seagull should be moving very slowly. It's 1 pixel, 30 pixels per second. Oh, and there they are. They are all flying across the screen. Very nice. Now, just like the number of seagulls, it would make sense. Let's see if we put this up to 10, we can move them across very quickly. Very fast. Let's go ahead and make a variable out of this, and let's call it Seagull Speed. So if we go back here, we were setting our other variables. Set variable Seagull Speed to a number, and we'll initially set it to 5. So now we run it. Whoops. What did we do there wrong? Let's take a look. We have those Seagull Speed Max, Seagull Speed Min. There we go. Okay, we're setting that up here. Speed. Okay, we are taking one extra step here because we're going to go on and give it a min and max speed, but for now, we will set the Seagull speed up here, and we'll say with our Seagull, we want Seagull dot, let's see, did we say, yeah, Seagull dot Seagull speed equals, and for right now it seems like an extra step, but it will make more sense in a moment, equals Seagull speed. Alright, so now we set our variable up here in this setup function, Seagull speed number equals 5, and then here we set the we created a dynamic property on this Seagull movie clip and said that the Seagull movie clip's Seagull speed is equal to our variable Seagull speed. So now, when we reference this here, down in the move Seagull, then we'll have to reference the movie clip's dynamic speed property rather than our variable directly. I'm going to go ahead and save this. It's just a good practice as you make progress. And this time when we run it, now again we have things flying by at 5 pixels per frame, but now we have a variable to control it. Now the reason we got an error last time is because the variable is out of scope. We were trying to reference a variable that was inside of this function from this one. I could have moved the variable out of this function and then it would have been in the proper scope. But with this case, now we want to set the speeds a little differently because now, as you can see, even though it's fun to watch them fly across the screen, we don't want all the seagulls to be moving at the exact same speed. We want them to be randomly, again, a little different. So to do that, we want to set up a maximum and minimum values that the seagull could be, because we don't want them to be so fast that they just whip by without being able to see and it doesn't look realistic. But we also don't want them to be so slow that they're just a fraction of a pixel per frame so that they just never make it across the screen. It just doesn't look like they're moving at all. So to get around that, we're going to take our Seagull speed variable and we're going to split that into 2. I'm going to set this into Seagull speed max and Seagull speed min. Now incidentally, the reason that by default Flash comes with a white background and dark characters for the code, it's personal preference, but I've found at times when you're staring at code all day long, it's a little easier on the eyes to have a dark color scheme with the background, just less pixels lit up in your face. So now we'll take our Seagull Speed, let's see, Seagull Speed Max, we'll still leave it 5. But then we'll create a Seagull Speed Min that we'll set to 1, which basically will mean that, again, the seagulls won't be so slow that they don't have enough, flight to get across the screen. So now that we have 2 separate variables here, now we'll go back to inside of our for loop that happens with each seagull generation, and each individual one's given its properties, and with all of this randomness going on, that's what makes each seagull a little bit different. So already you could start to see the power of using some scripting, which makes things happen different every time. It can add a lot of depth and complexity to your game, as opposed to manually placing seagulls on the timeline, animating and creating some kind of movie clip loop of them. Okay, so let's take a look at our set Seagull Speed code here in the finished example. Okay, so now we will set, instead of the 1 variable, now we're going to say that we want to set our Seagull Speed to math.random times Seagull Speed Max. Now if I don't put the Seagull Speed Min example in there yet, or catch in there yet, maybe you'll see some seagulls that are moving a little too slowly. Alright, so now they're moving at different speeds, which is nice. Let's go ahead and bump this up to 100 seagulls again to really get the overall effect. Okay, so now we can see some, like this character right here, is just going to take way too long to get across the screen, and we don't want any that are so slow that doesn't even look like they're moving. That might not seem as bad with a smaller one, but if we get a really large one that looks like that, that's just not so good for our flow that we'd like for our seagulls. So now let's go ahead and add that catch in a similar way that we added a catch for the bottom border for the seagulls to be placed on the screen in the Y dimension. Now we're going to check the same thing and see if the seagull speed is less than the seagull min. So from here we'll see, after we've already set it with the random times the speed max, now we'll check it and see if this particular seagull speed is less, right? Yes, is less than the seagull speed min that we set, which is set to 1. If that's the case, then we'll just want to set the seagull's speed to be equal to that minimum value. Alright, now we test the movie. Now all of our seagulls, all 100 of them at the moment, will be moving at least 1 pixel every frame and up to 5 pixels every frame. But again, we have a nice variable set here now to be able to tweak these numbers and decide how many seagulls we want, how far down we want them to go, and then how quickly or slowly they may be moving. Again, take one more look at it when we set it back to 20. A little more realistic, still quite a bit. Okay, very nice. Now finally, what we want is, alright, let's go ahead, and I believe the final one set it to 7 seagulls. Okay. So we'll set this back to where the student decided this was a good aesthetically pleasing number of seagulls. And there's one more issue. This guy flew by pretty fast over here. They're generated, they fly by, and then they just continuously move off screen and don't ever come back. And that's not as fun. We want kind of these seagulls to infinitely loop and to regenerate each time they come by. Now, very important when you're creating a game in Flash, specifically a mobile game, and this was intended to be targeted for the iPad, you don't ever want to continuously generate something without using what's called an object pool, meaning that we don't want to just generate 7 seagulls and then once they go off the screen generate 7 more and just constantly generating more and more and more, because all those will stay in memory and it will eventually get larger and larger and could become a memory leak and crash the game or crash the application. What we want to do instead is use a technique called object pooling, which basically means just generating a certain number of objects and reusing them. It's typical, we're not going to do it in this case because we're just doing something simple, but it's typical to keep your generated objects in an array and then just use that array to reference the objects again and again and again, such as bullets firing from a weapon. You would only generate as many bullets as that are necessary to see on the screen. You would constantly go through and regenerate in the array. What we're interested in doing though is we simply, when the seagulls move off the screen to the left, we simply want to move them back to the other side of the screen. So the same seagull in the same X, Y, or at least the same Y position. The X position changes over time. In the same Y position, the same random size will constantly regenerate across. So what we'll do is after we move the seagull, now within this move seagulls enter frame event, which again happens 30 times a second, so this is where you want to put all of your game logic, so to speak. We want to check for seagull reset. And we want to see if the seagull's X position is less than, if we just said less than 0, which is the left hand of the screen, which is as far as we want them to be, then we would see the seagull. Let's go ahead and try that just so we can see here. If the seagull.x is less than 0, meaning it has moved off the stage to the left, then we want to reset the seagull x to be stage width, which will send it back to the other side of the screen. So we'll see as they get closer, you can see that they disappear and generate back on the other screen. So we'll watch this large one here, and you can see we're almost there, but as soon as its beak hits, it disappears and then shows up back over here on the left. Now it looks like when they're regenerated, they're being placed off the screen completely because the seagull's registration point must be right at its beak, and that looks correct on the right side. But on the left side, we actually want them to go the length of their body as well before they disappear. So inside of here, instead of saying is less than 0, we want to say is less than seagull dot width, and then multiply that by -1 to give us the negative value, since that's the direction that we're moving. And it looks like that we also decided to go ahead and add the positive seagull.width when placing it back across the other screen, which may or may not be necessary, but I actually like that because it will give a moment of time between when it cycles from one side of the screen to the other. So we'll run our movie. And there we have some generated seagulls that are going off one end of the screen completely and then showing back up on the other. I'm going to save my file just to make sure. So we have 54 lines of code. It's not too bad, with some comments. It can look a little daunting if you just stare at it at once, but if you piece things together, which is how code is written, a step at a time, and just organize it as you go, eventually we'll have a nice little piece like this. So let's just test, and let's give ourselves, let's go 25 seagulls just to see a whole bunch of them and make sure they're following all the rules we anticipate. And you can see that some of them will show up on top of each other, and some larger ones will show up behind smaller ones, giving the illusion of the depth a little off. And these are things that, you know, are nominal and we're not really interested in fixing in this game. But it's worth noting, and that can take into effect what number we end up finishing with. So if we finish with 7, that gives us, again, the student-chosen, nice, aesthetically pleasing value. So each time we run our movie, 7 seagulls are created out of the same movie clip, and they're randomly placed on the screen, X and Y. They're moving across at random speeds, they're random sizes, and they will consistently loop and come back through the other side. So from here, you can see that this is the beginning of how you can start generating characters for games or applications or something. And in this particular game, the next step would be to take this beyond the title screen and work into the actual gameplay, where I'd assume with a title like Seagull Squat, you would have some kind of crosshair cursor and find a way to knock these poor harmless seagulls out of the sky. So I hope that helps you get started with creating some simple games in Flash with movie clips and generating them dynamically, generating some game characters dynamically by creating a linkage identifier in the library, and then dynamically generating the game characters and giving them properties and moving them along in ActionScript. Thank you for watching.